What is crystal structure? Next, what is the structure of the energy band? Crystal structure and energy band structure. Crystal structure. A crystal structure is a three-dimensional arrangement of atoms or ions in a solid material. This arrangement is periodic and regular, with atoms or ions spaced at specific intervals and directions. Crystal structures are a major area of study in crystallography and play an important role in determining the physical and chemical properties of materials. One of the simplest crystal structures is the cubic structure, which is found in a variety of materials, including cubic and perovskite structures. The crystal structure determines the physical and electronic structure properties of various materials depending on the specific crystal structure, so materials with the same chemical composition can have different properties depending on their crystal structure. Energy band structure. The energy band structure is a concept that describes how the energy states of electrons are arranged in a solid material. Electrons in a solid material exist at energy levels, energy bands, and the energy band structure explains how electrons are located in loud energy states. The energy band structure can be broadly divided into two types. 1. Valence band. A valence band is a collection of energy levels that can be occupied by electrons. 1. The top portion of the valence band represents a spatial range that can only be jumped when an electron moves to a higher energy state. 2. Conduction band. A conduction band is a collection of energy levels that an electron can move to when it leaves its current electron energy state. The energy band structure plays an important role in determining the electrical conductivity and properties of electrons. Metals are good electrical conductors because the valence band and conduction band often overlap, allowing electrons to move easily. However, semiconductors have a gap between the valence band and conduction band, limiting electron mobility, and insulators have very low electron mobility because electrons cannot move between energy bands. The energy band structure is important for explaining the interaction of electrons in solid materials, and understanding the operation of electrical and electronic devices. Here are some additional details about crystal structures and energy band structures. 1. Crystal structures are determined by the arrangement of atoms or ions in a solid material. 1. The most common crystal structures include cubic, hexagonal, and orthorhombic. 2. The energy band structure is determined by the interactions between electrons and the atoms or ions in a solid material. 2. The energy levels of electrons are determined by the potential energy of the atoms or ions. 3. The properties of a solid material are determined by its crystal structure and energy band structure. 3. For example, metals have a high electrical conductivity because the valence band and conduction band overlap,